Welcome to an introduction and walkthrough of CraftUnique's Craftware slicing program. This program allows you to take a solid object and translate it into a language that the 3D printer can use. It is available for free to download at craftbotusa.com/craftware, and all you have to do is hit this Get Craftware link. Once the program is installed, you are able to take a simple STL model and import it for slicing in the program. For this example, I'm going to use this model Rose by 3D Printer Superstore on Thingiverse. When you open Craftware, you'll notice immediately that you have a large build platform. Along your left side, you have your new project, open, save, and save as tabs. On your top, you have your undo tab for if you make a mistake, add to add models to the build plate, select to select whatever models are on the build plate, move to move around the models, rotate to rotate the models, scale, which allows you to change the model either by percentage or by physical length, drop, which allows you to put the model down flat on a plane, or bisect, which allows you to split the model into different pieces if necessary. Split allows you to take a larger model and make it into smaller models, and auto drop automatically places all your models down flat on the bed. On the right side you have the support button, which we will get to in a minute, the slice button, which allows you to move forward to the next step, and the options button, which allows you to change model settings and program settings. Now the first thing we're going to do is add that Rose model that we downloaded earlier. Now when it appears, you are able to rotate and twist the model around to take a look at it, and if you go to scale, it will allow you to see just how big this model is. Currently this is 80 millimeters wide by 75 millimeters tall and 71 millimeters deep. If I need it to move around the build plane, all I'll do is move, and you can drag around the model to where you need it. Note that if you go into or out of the build plane, it will automatically snap back to the surface. If it does not automatically drop, check to make sure auto drop is still active. The next task could be to rotate it. So if I rotate the model, you can do this one of two ways. You can either click the model and twist it along one of these assorted arrows, axes of rotation, or you can type down at the bottom, noting that the color corresponding to the axis is the one that it will rotate around. For example, this X is red. If I put 90-degree rotation along the red axis, it will rotate 90 degrees along that axis. Same goes for blue, and same goes for green. It is important to note that some models you may work with may have large, steep overhangs. This model isn't too bad, but for example, right here on these pedals, there may be too much overhang to allow the model to print correctly. So, what we will do is go over to the Support tab, and all you need to do is click Auto Generate Supports. Now you can see that the Craftware software has inputted supports on places where it thinks that the model will fall without proper support. You can also change how thick these supports are with the support bar thickness, and you can also change the minimum surface steepness. What this means is that right now it's set to 60 degrees. It's looking for any surface that tilts further out than 60 degrees and it will support it correctly. If you do not wish to keep these supports, all you have to do is click Clear All Supports. Now if you print your model and find that it's collapsing, you can simply add support to it individually in specific places just by clicking on the model, and you can see the supports generate as needed. Once you are done preparing your model and you're ready to slice it, all you will do is click Slice. Now there's two modes to Craftware. If you're a basic user and you just need a simple piece printed, all you have to select is high quality, the PLA material that we are using, and then slice. This will give you a quick demonstration of how the printer is going to operate while printing your model. From this point, you're able to click down at the bottom and change the layers to see how it's printing, and change the specific point at which the 3D printer is laying down the material, the filament. On this screen, there's two things of note that you should pay attention to. Up here in the statistics box, it gives you an estimated time and then a length of material used. This time is typically wrong and is usually about 25% more. So for example, this one says it's going to take 5 hours. more than likely this print will take about 7 hours. As you have a 4-hour time limit, it is imperative that you make sure you're not excessively exceeding your time. From this point, all you need to do is hit save for this G1 logo, and then save this G-code file onto the flash drive that you're using for 3D printing. Now that's the end of basic use. This can get you through most prints. However, if you want to become an advanced user, we will now go through all of the subsettings and adjustments and what they do. Now let's say you want to become a 3D printing master user. I use the term master jokingly, but you'd like to know what's going on, more so in the print. So just like before, select Slice, and then now you can select Switch to Expert mode. This will pop up a rather large window with many settings. Now before I go over any of these, I want you to notice that if you click on a box, it will tell you what this box does in the lower left corner. But I will now go over more of the general use settings. Extrusion width on the first line, this is the width of your nozzle. The nozzle that we provide you is 0.4 millimeters. We do have a couple bigger and a couple smaller, but that will require special use case appointments or you to contact us for any purpose. But otherwise, 0.4 is the extrusion width. It's important to note that this is a factor for your wall thickness. As you can see in this graphic, the white line followed by the red line is 2 passes of the nozzle. That means this width of the wall is currently 0.8 millimeters, which is 2 times the nozzle width. The next one is your layer height. This is how thick each layer is as it passes, so each one of these white lines is the layer height. 0.2 is typically decent quality but still a rough grain. 0.3 and 0.4 are for much faster prints without a lot of precision, and 0.1 would give you almost the finest possible by these printers. However, it takes a lot of time because you're now printing twice as long. The draw speed is how quickly the nozzle moves as it's printing. Typically 60 millimeters per second will get you through whatever you need. The filament diameter is just that, the diameter of filament we are using. We provide you with 1.75 millimeter PLA, and you should not need to change this setting no matter what. Flow adjust adjusts how quickly the PLA is coming out of the nozzle. If you're working with very fine pieces or pieces with a lot of start and stop, you may have to adjust this flow adjust higher or lower if you find that you're over extruding or under extruding. An example of over extruding looks like a pimple type surface, and under extruding would be not fully covering or cavities in the print. The next line down is the loop count. What the loop count is the number of passes on the outside walls. As we said before, under extrusion width, we currently have 2 passes, which is shown here in loop count of 2 loops, and the line right below it showing that the wall thickness will be 0.8 millimeters. If you need a stronger model, you can increase this loop count. For example, I'll go to 4 now, and you can see that the outer loop is now 4 passes, or 1.6 millimeters thick. The next bunch of settings are not really relevant. It allows you to adjust the speed and width of the perimeter as you go around. However, there's no need to change them. The loop density and width is another way of modifying the wall thickness. However, I do not recommend changing that. Coming back up to the top, you can set what kind of surface that your model will have on the top and bottom. You have 2 options: parallel lines, which are just that, literally lines that come back and forth, sealing in the object, or you can do concentric, which changes it to closing squares, circles, or rectangles. The difference between the 2 is minimal, as you should have multiple layers going across, and this cross lattice will keep it from breaking and separating. The next line below that is how many layers you want to have on your top and bottom. It is important to note that these are related to the layer height just to the left. So for example, if you're laying down a layer height of 0.2 millimeters and you want 4 layers on top, you will have 0.8 millimeters of thickness in your wall. So typically your top and bottom layers you'd want to be identical with your loop count to give a consistent shell all the way around. Your density and width, again, you'd want to leave at 100, just as the loop density width, it lets you thin or thicken the surface of the top and the bottom, and your speed you'll want to leave at 100. The last thing on this tab is called the infill. What this is how much filling of the model you are doing. It's important to note that many of these models are not solid, as that would be a large waste of plastic and take forever. So the very first box gives you a selection of what type. You can do parallel lines, you can do a square grid, a triangular grid, 45-degree grid, 36-degree grid, and 30-degree grid. The most common one you will be using is parallel lines. The difference between these is minimal, but if you really wish to change it, you can. The next box gives you the density of the fill. So 100% fill would be a solid object, and a 0% fill would be a completely hollow object. Both of these are extremely impractical, as a 100% solid object would take way too much material and way too much print time, and an object with zero infill would collapse on itself and could not have a surface. Typically, you will use anywhere between 15 and 25%, depending on how sturdy you need your model to be. It is rare to see an advantage of going over 50% infill, as by that point, the lines become very small and very intertwined. If you're finding that your print is taking too long, this is one of the first things you should look at and decide whether or not you need to run as thick of density as you are. The next line is the speed, which again you shouldn't need to change, and the angle increment changes how aggressively you want these lines to cross. The last setting here is a neat one, however it has a very specific use case. It's called Vase mode. What Vase mode does is take the extruder nozzle and follow the outer perimeter of the part continuously without lifting the nozzle. Now for this to work, you must select a piece that is a continuous cross section, meaning something that is a solid circle or a rectangle, but something that does not have overhangs or does not have a lot of breakups. So this is something you can play with, however I do recommend doing a little more research about it and your part before you try it. The next tab is the Advanced tab. On this tab, there's nothing that you really need to adjust unless you really wish to become an expert 3D printer, except the travel speed. Now if you're printing an extremely finite part or something that just requires a lot of starting and stopping, there's two speeds you're going to want to drop down. The first one is the draw speed. The default setting of 60 millimeters per second is actually quite fast. If you're working with a piece that's extremely precise or again has a lot of broken up start and stop bits, you'll want to drop this down. The second one is the travel speed. Both of these are the default speeds currently, but essentially that's how quickly your nozzle will move to each position and layer down the material. Keep in mind you're talking about melting plastic, and it does not exactly have a perfect start-stop. The next tab we're going to look at is the foundation. The next tab we're going to look at is the foundation. Now on the foundation, this will define how you want your first layer to go down. You have the choice of a skirt, a brim, and a raft. The difference being, a skirt simply outlines a line around the model to prime the nozzle and essentially make sure the material flow is correct. You can set 1, 2, 3 loops and then how far you want it to go away from the model. I recommend this at the very least simply to ensure that any material that's melted out of the nozzle has been removed and the nozzle is flowing correctly. The next selection is a brim. A brim simply extends the surface of the first layer. So in the event of using a model with a very small surface area that won't stick to the bed correctly, a brim basically takes a tiny footprint and makes it really large to help the model stick to the bed. Because if the model doesn't stick to the bed, it's going to fall off and the print won't work correctly. So you can set how many loops you want the brim to do, with each one obviously increasing the surface greater and greater. This piece is then simply broken off or trimmed off and it goes away. The raft functions much like the brim, so it basically supports the entire model. So in the event of using a model with a very rough footprint or not a whole lot of textures flat on the bed, you can use a raft to support the model. However, this is again something you'll have to play with yourself to figure out if it works perfectly for you. Now the next tab is the temperature tab. There's 3 to 4 main settings here we need to look at. The first one is the fan. In the event of printing PLA, which you should be doing most cases, you will want the fan to cool. This fan ensures that once the material comes out of the nozzle, it is properly cured and dried before coming back around to the next pass. The speed of the fan is settable here. Again, with PLA, you typically want to have 100% fan speed and you want it to come on after the third layer. Now, if you're using something like ABS, which again is a special use case, you'll want to talk to one of the lab techs to figure out the correct settings. ABS is very temperature sensitive and you do not want to run fan, but you can get more information on that by asking your lab techs. The next settings are the bed temperature and the head temperature. Each material has a specific temperature that it's required to run to print correctly. The PLA that we provide you prints best at 205 degrees Celsius. However, it has a range of 190 to 215. If you feel the temperature is too high or too low, there's many different troubleshooting guides out there that can help you identify temperature-related problems. And again, if you're using ABS or any other fancy material, talk to your lab techs to find the right temperature to use. Same goes for bed temperature. PLA typically needs 60 degrees Celsius. However, certain other materials could require higher or lower. The next two tabs are largely irrelevant. The G code allows you to set a custom header or footer, which you do not need to do, and it allows you to change the format of the text. If you wish to know more about these, you can read about it in the lower left corner. The dual extruder tab is also irrelevant as the Craftbot XL does not feature dual extruders. And that pretty much completes the advanced walkthrough of the Craftware software. From this point, you should be able to reliably print any model you need, and if you cannot, simply contact your lab techs and ask them for help and they will help you.